Okay, so far we've been factoring trinomials. We're going to do one lesson on how to factor polynomials with 4 terms. So this time we've got 4 terms instead of 3 terms. How we do this is what's called factoring by grouping. And what you're doing basically is you're using the distributive property to factor. We're undoing the distributive property. And we're grouping them in 2 different terms at a time. So what we do is we first look at this first group, 4x cubed plus 8x squared. We're going to factor that separately. So we're going to look at 4x cubed plus 8x squared to see what our greatest common factor is. Now, I know a lot of you are used to writing this out where you do 2 times 2 times x times x times x and all that. You need to start figuring out how to do it without having to break it down like that. So we're going to begin that process. If we look at 4 and 8, the biggest common factor is 4 because 4 goes into 4 and 4 goes into 8. So we're going to take a 4 out. We know that for sure. And then to figure out how many x's you're going to have, it's going to be the smallest amount of x's you have in a term. So the least amount of x's they can have in common is 2 of them. Because 8x squared, that has 2 x's. That means we're going to take 2 x's from here, and 4x squared will be our greatest common factor. So 4x squared, and then what we do is we write what's left in the parentheses here. If we take out 4x squared, we are going to be left with just an x in that term. And then 8x squared, we take out all the x squareds, and we're dividing 8 by 4, so we have 2. So it's going to be plus 2 is what you have left in each of these. And you could do this writing out this big, long stuff where you write out each and every single term and then circle what's in common, but you've got to start getting used to not having to do that. For now, if you need to do that process, that's fine, but ultimately you're going to need to be able to do it without having to write that out. Now let's look at the next group. We have a negative 5x and a negative 10. Now, we have, since they're both negative, we definitely have a negative in common, okay? So we have a negative in common, and then between the 5 and the 10, we have a 5 in common. So it's negative 5 is what the greatest common factor is. There's no x's because 10 doesn't have any x's, so they can't have any x's in common. And then when we circle or use our parentheses, what's left then, if we've taken out a negative 5, we're basically dividing this whole thing by negative 5, which will leave us with x. Here we divide negative 10 by negative 5, we get plus 2. And again, you could get this if you factored it out like negative 5x and then negative 5 times 2. You can see that negative 5 is what's in common, and that's where we got this negative 5, and then we have x plus 2 left. Now what we do, pay attention to this part right here. What you do now is you take both of the greatest common factors, 4x squared minus 5, and you put those together. 4x squared minus 5, and we put those together in the same parentheses. So these are our GCFs in the same parentheses. And then what we do, if you notice, this x plus 2 and this x plus 2 are exactly the same. That's what we wanted. That will be our second factor. But you only want one of those. You only want one of those for the second factor. So this right here is the factored version of that 4-term polynomial. All right, so let's keep doing these. If you're still not quite getting it, that's okay. Just write this down, and I'll answer questions tomorrow as well, but we've got several more examples to do. By the end, you should be able to be comfortable with it. For letter B, we have 5p to the 4th plus 20p cubed plus 6p plus 24. So we're going to take these in groups. We're going to first take 5p to the 4th plus 20p cubed. We know they're going to have p cubed in common because the least, look at the term with the lowest exponent, and that's how many p's we're going to have in common. And then look at the numbers, 5 and 20. So the greatest common factor there is going to be 5. So we're going to take a 5p cubed out of there. So what will that will leave us with up here is that'll leave us with a p. And then here, it'll leave us with a 4. Now we'll do it again with the next 2 terms. 6p plus 24. They don't have p's in common, so they're just going to have a factor in common. And that factor, if you look at it as 6 and 24, that factor is going to be 6. So we have a plus 6, and I'm going to keep that sign with it, that plus 6. And then if you look, we have a p left, and then if we take a 6 out of there, 6 and 4, then we're going to have a 4 left, so p plus 4. And then notice these match, and they should match on these factoring by groupings. And then one of your factors is going to be your GCF ones, 5p cubed, and then plus 6. And then the other factor will be just one of these that are alike. You only want one of those. Now, sometimes, and we've done this on almost all the ones that we've factored so far, sometimes before you can start either the grouping or the hangman or the special cases and that kind of thing, you first have to look at each one of these polynomials and see if there is a common factor out of all the terms of the polynomial. And if so, you have to do that first. And that is the case with the second example. On this second example, before we start factoring by grouping, you have to notice that these things have stuff in common. They all have something in common. If you look at the numbers, 12, 10, 36, and 30, they're all even numbers. So we know we're going to factor out a 2 because they all have a greatest common factor of 2. The other thing to look at are the variables, because your variables here, they all have at least one y, because even this last term has a y in it. So because of that, we need to take a y out of all 4 terms also. So we're first going to factor out a 2y before we begin our factoring by grouping. If we take out a 2y out of 12y to the 4th, that's going to leave us with a 6, and then we've already taken one y out, so we have 3 y's left, so y cubed. And then do that with the 10y cubed. So 10, take out a 2, we're going to have a 5 left, so we're going to have 5 and then y squared left. The next one, you're going to have a negative 18y. And then if we take a 2y out of this one, we're going to have negative 15. So on these kind, when they're bigger numbers like this, usually there's a big common factor that we can take out. Now we can't forget about that. We're going to come back to it later. Now we're going to look at these remaining terms in here and go ahead and factor those by grouping like we did on the example before. So now looking at 6y cubed plus 5y squared, the numbers don't have anything in common. However, we have a y squared in common. They each have at least a y squared. So if we factor out a y squared, on this side we're going to be left with 6y plus 5, because we've taken out a y squared. Now looking at the next group, negative 18y and negative 15, they each have a negative in common, so we're going to go ahead and put a negative out there. And then if you look at the numbers, 18 and 15, 3 will go into both of those numbers. So there's a 3 in common. There's no y's in common because the 15 doesn't have a y with it. So now we take out a negative 3 factor, so that's going to leave us with a 6y. Here, if we've taken out a negative 3, we have a positive 5 left, so plus 5. Be careful with the negatives and positives things. If both terms have a negative, then the negative has to come out. And if the negative comes out as a greatest common factor, what's left, everything is positive inside. So be careful with that. So then we're going to go and put all this together. Now, remember this 2y back up here, we have to put it back into this situation. So when we write out the factors, we're going to put the 2y out front. Then we're going to put our GCF terms, y squared minus 3. And then finally, we're going to put 6y plus 5 out there. These are the factors of that 4-term polynomial. So see, that 2y did have to come back into play. Okay, and then letter B. Letter B does not come out. There was some mistakes in that example, so we're not going to be able to do example B. But this is how we factor polynomials with 4 terms. The first 2, we just went ahead and did the factoring by grouping. And then the last example here, we had to first factor something out of all of them, and then do factor by grouping, but you can't forget about this part up here. It has to come back down. And that is how you factor by grouping. Thank you for listening.